a six-sided die is tossed 5 times in succession rather than just twice, then each possible outcome is an ordered collection of 5 numbers, right? 6 possibilities, 6 possibilities, 6 possibilities, 6 and 6 possibilities. So you calculate it and it comes to 7,776. So the book says we will call an ordered collection of k objects a k tuple. So you have 5 objects here. You can call it a 5 tuple. So each outcome of this experiment, die tossing experiment 5 times, is then a 5 tuple. The product rule says, suppose a set consists of ordered collections of k elements, k tuples. So you call one outcome, say A. So you remember you had ordered pairs A, B. That would be a 2 tuple. This would be a 5 tuple. Right? This is an ordered collection of k objects. Suppose a set consists of ordered collections of k elements, k tuples, and that there are n possible choices for the first element. There are n possible choices for the first element. For each choice of the first element, there are n2 possible choices of the second element. So for the first element, say we have these 6 choices. For each number of choices for the first. For each choice of the first element, we have a certain number of choices for the second element. In this case, say you choose 1 here, then how many options do you have here? You have all 6 options in this particular case. And so for each number here, you have 6 choices here. Then there are how many possible 5 tuples do we have here? We have 6 into 6 into 6 into 6 into 6. So it says n1, n2, n3 and nk was into nk. Fill in the missing n's, nks or njs or whatever. So you take the number of possible choices here, and for each possible choices you multiply that 1 with the number of choices here, right? The number of possible branches here. So all the end points you get, all the end outcomes you get. That would be, say you have So you have 1 here, then you have 6 choices here, 6 choices here. Okay, you have 6 choices here. Now you take 1, 1. Then you have 6 choices here. Okay, and then you take 1, 1, 1. You have 6 choices here. So overall, how many variations you can have in this ordered tuple? That would be your total number of outcomes. So an alternative interpretation involves carrying out an operation in k stages. Alright. The first stage can be performed in n1 ways. You have 6 ways of performing the first stage of this experiment. Right, you can get 6 possible outcomes. If you toss this six-sided die, and for each such way, there are n2 ways to perform the second stage. For each of these ways, either you get 1, 2, 3, 4 or 5 or 6, then you have 6 ways to perform the second stage, right? 6 possible ways of 6 possible outcomes of the second stage, and 6 possible outcomes then of the third stage, no matter what you are getting in the second stage. At each of the possible outcomes of the second stage so you have 6 possible outcomes of the third stage. So how do you get the total number of outcomes? You multiply all the 6 into 6 into 6 into 6 into 6. Right. So now, for example, a college town has 4 pizza places, a theatre complex with 6 screens. College town has 4 pizza places, a theatre complex with 6 screens. And 3 places to go dancing. Then there would be 4 first generation branches, 6 second generation branches emanating from tip of each first generation branch, and 3 third generation. That would be one way of writing this. Another simpler and neater way would be that's how often I have written these. Right. And then you have 3 right. This is just quite impossible, quite difficult to show. So now each possible 3 tuple in this example would correspond to the tip of the third branch, right? But how many tips do you have here? We have 4 tips here. But how many tips do you have here? We have 6 into 4. That would be 24. And then how many tips do we have here? We have 24 into 3. That would be 72 possible tips. Okay, so suppose the home remodeling job involves first purchasing several kitchen appliances. They will all be purchased from the same dealer. And there are 5 dealers in the area. Okay, so the home remodeling job was about, you have a homeowner doing some remodeling, requires the services of both a plumbing contractor and an electrical contractor. There are 12 possible options available of plumbing contractors. Nine electrical contractors, right? And yeah, so suppose that the home remodeling job involves first purchasing several kitchen appliances. They will all be purchased from the same dealer. Kitchen appliances have not been specified, but certain things need to be purchased from the same dealer, and from one dealer everything has to be purchased according to the question. So there are several 5 dealers. There are 5 dealers in the area, with the dealers denoted by D1 to D5. There are how many tuples then? You have to choose these, and then you have to choose among dealers for purchasing, for the purchase. Okay, so if your tuple is D, I, P, I, E, I, that is a 3 tuple. How many options do you have? You have 5 into 12 into 5, that would be 25 into 12, that would be 50. 5. So that would be 300 cents. Okay. So that would be 9. That is 9. So you get 540 possible tuples, 3 tuples. Alright, so that is your example 2.19. So permutations and combinations. Now, how is permutation and combination different? An ordered subset is called a permutation, and unordered subset is called a combination. So what happens if you have, say, 3 or different objects and you have to find all possible combinations and all possible permutations? Which will be more? In how many will you get more permutations or more combinations? You will get more permutations, because say you have 3 placeholders and you have 3 different objects, and then you have to arrange them with replacement, then you get more number of permutations, as you will get more 3 tuples. That is your ordered triplet, right? Something like that. So the number of permutations of size k that can be formed from the n individuals or objects in a group will be denoted by pk. The number of permutations of size k that can be formed from n individuals or objects in a group will be denoted by p, k, n. So n objects and k placeholders, right? Individuals, objects. Now, so permutation. Unordered subset, and combination. Combination is an unordered subset. One way to denote the number of combinations is CKN. Where K is the size of the number of combinations of size K that are being formed, and that would be your placeholders, and n would be the number of individuals or objects. Suppose, for example, that a college of engineering has 7 departments, which we denote by A, B, C, D, and F and G. Each department has one representative on the college's student council. Now, how many? Let's write this. How many departments does the College of Engineering have? And department has one representative on the college's student council. Okay, so from these 7, so there are 7 departments and there are 7 representatives. One is to be chosen as chair, another, so different placeholders, chair, then vice chair, then secretary. So this is a so how many ways are there to select the 3 officers? So 3 tuple. That would be a possibilities of the 3 tuple. Now, does the order matter? Yeah, we are saying that the first is chair, second vice chair, and then that's how it will be easy to identify. So, all possibilities of the 3 tuple. So, if the first, and this is without replacement, the same person, the question is, in the question it seems like 3 different people are going to be these 3 different officers. So in the first you have 7 options, second 1 will be chosen, then you have 6 options, third will be chosen, then you have 5 options. Then what do you have here? We have 42 into 5. So 210. 3 tuples. Options of these possible ways to select these 3 officers. Now is there a short way to do this? There may be a short way to do this. So how do we write P of? We have to choose, so the tuple is of size 3. The 3 tuple is of size 3 that we are looking for. And we have 7 options, 7 individuals or objects to be chosen from. So now how do you, is there a short way to write this? Do you have a formula here? Let's see. Alright, we'll come to the formula later, but let me show you something simple, which is a factorial. What is a factorial? So your n factorial, this is just a denotation of n. It takes positive natural numbers and 0, or say positive whole numbers. So we have n into n minus 1 into, so n factorial will work where n belongs to positive whole numbers. This set. What are positive whole numbers? Positive whole numbers are just positive integers. right, including 0, including 0. So that should come in. So whole numbers is actually 0, 1, 2, 3, 4, 5 and so on. Alright, so and natural numbers start from 1, 2, 3 and so on. Okay, so factorial is just this and it goes on till 1, right? So this is your factorial. We come soon to how we can denote a permutation. So one way to we wrote this as 7 into 5 into 6, sorry, 7 into 6 into 5, right? We can also denote this as 7 factorial upon 4 factorial, right? And what is this? This is P 37. So P37, if P37 is this, then what should be P of n k? Sorry, P of k n. P of k n should be, in this case, your n factorial n minus k factorial, because n minus k, if this is k and this is n minus k is 4, right? So we also have a simple formula.